Hello everyone, it's great to have you all on board. So another time with tutorial, fantastic tutor. And in today's tutorial, it happens to be the very last revision class we're having on the course G, MTH105. It's been a wonderful one. It's been so interesting of the course. And you know how things have been done. We take the theory, then we take the calculation. So now, for your information, a lot of calculations are in course. All right, and definitely we cannot cover everything in just this revision class. So I beg you, for those who are willing to take the bull by the horn, you can check the description of this video. For those who knows how to check the description of the video, check the description of this video and find the link to all the only calculations. We treated each of these calculations one by one. Only calculation. The link is there. All MTH105 calculation keynotes is in the description of this live stream. But if you can't figure that out, just send me a direct message after this class. Go to the website www.star.net and use the WhatsApp button on the top right hand corner to send me the direct message for the calculation. I know majority of you have gotten the keynote, but if you have not gotten the keynote, there's a theoretic part of the keynote, the theory part, there's a calculation part too. Please take note of this. So I'm going to be taking a few calculations and I'm going to be taking some theoretical questions as well. Wow, interesting. Some theoretical questions as well. So we're going to be taking both, and it's not going to be a long class because we have another class by very soon. So with this being said, let's up straight into. But before then, I need to go and use the generator set. Since give me a moment. Let me quickly turn on the generator set. Ìfẹ́ Ìfẹ́ kí ló ṣẹlẹ̀ iná ṣì wà náà? Ṣé o lo orí káàdì yẹn ló lánàá ni? O dẹ̀ ṣọ́n pé o lóde. Mm. 4 points here, correct. 2011 for 4 points. Okay, sorry about that. Just need to use the generator set there. Resolve that later after the class. Can we all hear me now? Okay. Wonderful, wonderful. Good evening, everyone. So let's start immediately. Our time is fast spent. So to start with, we are starting with the theory. Okay, we are starting with the theory. Now, question one. Let's take the first question for tonight. It says here, mathematics is the science of numbers and dash. Is the signs of numbers and dash. Okay, mathematics is the number or is the science of number and dash. Okay, who's helping with that? So we have that as our first question. Yes, wonderful. The science of numbers and shape. Awesome. Okay, science of numbers and shape. Awesome. Shape. We have question 2. It says, awesome. Thank you very much for that. Question 2 says, dash is the science of reasoning or explaining events. Dash is the science of reasoning or explaining events. Dash is a science of reasoning or explaining events. Okay. Dash is a science of reasoning or explaining events. Yes, we have that as logic. Also, logic. Now, let's take this. It says, all right, let's take this question. Any matrix which has the same number of rows as the thing for the network, I think it's stable now. Any matrix which has the same number of rows and column is called dash matrix. Let's keep the answers coming. This is exam we're having tomorrow. I'm expecting more from us. Let's keep the answers coming. Okay. Wonderful. Square matrix. Okay. Question 4. It says here, a dash is a physical quantity which has magnitude and direction. Which have magnitude and direction. A dash is a physical quantity which has magnitude and direction. Yes, a vector. Wonderful. A vector, yes. Question 5. It says, dash. Now let's take this. It says a vector can also be defined as a directed line dash. As a directed line dash. A vector can also be seen as a directed line dash. Wonderful. Directed line segments. Awesome. Okay. Now, let's take this. A dash is a locus of a curve. Is a locus of a curve. A dash is a locus of a curve. Awesome. Circle. Wonderful. Yes. A circle. A circle is a locus of a curve. Let's squeeze one more question here. It says, dash is the amount by which a resource is underutilized. Amount in which a resource is underutilized. In which a resource is underutilized. Dash is the amount in which a resource is underutilized. What's going on? The comment section is a bit dry. Have we not gotten our keynote? What's going on? Have we not been studying? Yes, we call that slack. Awesome. Slack. Now let's take the last set of theory before we take some calculations and we can call it a wrap. Just like I have said earlier, for those of us who have not been, all right, who have not been following, there's a calculation. The keynote for all the calculation in MTH105, all right, is available. All are pure videos, selected and carefully arranged, all right, so that you can learn and understand very quickly all the calculations in this course. So just reach out to me after this class and I will send it to you. All right, after you have responded to the requirements. Are we together? It says just a moment. Question 8. Now let's take this question. All right. Dash is a vector whose position in space is fixed. Let's take it this way. Dash located vector dash located vector, okay, is a vector whose, okay, point in space is fixed. All right, whose point, excuse me, in space is fixed. Dash located vector, all right, is a vector whose, all right, point in space is fixed. Okay. Wonderful. Yes. Wonderful. We have point located vector. Now let's take this. Dash vector have magnitude and direction, but have no particular position. Have magnitude and direction. And direction, but have, okay, but have no particular position. No particular position. Dash vector have magnitude and direction, but have no particular position. Position attached to them in full, but we just have to reduce that. Also, free. Now, like I said, we have the keynote to the course, and a whole lot of theoretical questions are there. Okay, we can get it after this class and practice with it. So we're just going to take a few more questions and we can start with calculation. The vector A and B are said to be dashed if they have the same magnitude and direction. The vector A and B are said to be dashed if they have same magnitude and direction. Are said to be what? If they have same magnitude and direction. Yes, equal. Wonderful. Are said to be equal. Okay. Question 11. Now it says, just a moment. Okay. Stationary value are also called the dash points. Stationary values are also called the dash points. Also, they are also called the turning points. Now let's take two more questions and we can start with calculation. Dash is a sequence which differ by common difference. Dash is a sequence which differs by a common, all right, difference. Okay. So very quickly, we are taking some few questions on calculations. Like I said, there are a lot of calculations, all right, but we can only cover just a little. Okay, so please note that after this class, request the calculations, all the calculations, a whole lot of them, almost 20 different types of calculations, 20, or more than, if I'm not mistaken. Yes, we have AP. Okay, so very quickly, trying to see how I can save time for the other class because I have scheduled the other class for 8:20. So next 15 minutes, let's take some calculations. So the very first calculation we're going to be looking at all right, is this general term of a sequence. Okay, general term of a sequence. And the formula for general term of a sequence is said to be n plus 1 over 2, all right, into bracket n minus 1. Okay? Yes, thank you very much for that. So now let's take a very quick example on this. Now, if n equals 1, 2, 3, find n1, n2, n3. Now, for n1, all right, for n1, we have, since our formula is n plus 1 over 2 into bracket n minus 1, then we have this n, our 1, represents n here, all over, all right, 2 into bracket 1 minus 1. This we have 2. If you have to multiply this, it's going to give you 2 minus 1. And we have 2 over 1, which is still equals to 2. Now, I'm going to solve for n2. Please solve for n3. Okay? So I'll be solving for n2. So let's solve for n3. If you have your calculator, please start solving for n2. n3, I mean. Okay? Okay, so now what's your answer for n3? So what's your answer for n3? Let's solve for n3. What's your answer for n3? Okay, are we there? Okay. Okay, thank you very much for that. So now we have that as general sequence. So let's take something else. I believe we understand the process for general sequence. Now, we have, there's something called common difference. Okay, and to find the common difference, okay, thank you very much. Thank you, everybody. Thank you for the attempt. Miss Isaac Akanji, you need to check again. Are you sure that 2 is correct? Just take your time and check. Now, there's something called common difference, all right, which is usually n, all right, 2 minus n1, all right, or it could be Yeah, N2 minus N1 for common difference. Now let me explain this. Let's say find the common difference of 1, 2, 3, 4, 5. All right. I used N1, it could be A2 minus A1. Now, according to what we have here now, this is, all right, A1, A2, A3, and that's how I continue. So to find the common difference of this sequence now, what are we expected to do? Simple. That is 5 minus 4. All right? Or 3 minus 2. Or 2 minus 1. Anything you get, you still arrive at the same answer. Anything you get, you still arrive at the same answer. That is that for difference. That is that on common difference. A2 minus A1, you have your difference. That's nothing to dwell on much. Now look at this. It says, find the seventh term okay. Find the seventh term. Like I said earlier, for those of us who need detailed explanation on calculations on this course, simple detailed explanation, request the keynote after this class. It says seventh term, okay, of an AP, all right, whose first term is 102, okay, and a difference of minus 3. Now, when we say seventh term, there's a formula, okay? The formula is, we have UN equals A plus open bracket N minus 1 close bracket, and we have D. That is the formula. Simple, because this is simple and straightforward, because we have, all right, everything we need. Now let's list it out. The seventh term of an AP. Find the seventh term. So we already know our N as 7. All right. First term, which is A, as 102, and the difference, which is minus 3. So you can see that everything is resolved. All right. Our A is here. Our N is here. Our D is here. And we can start interpreting. How do we interpret? We have U7 equals 102 plus open bracket 7 minus 1 close bracket minus 3. We have 102 plus 6 minus 3. We have 102 plus, when you use this minus open this, it becomes positive. So we have 6 multiplied by 3, that should give us 18. All right, so this should be negative 18, not positive 18. Okay, if you use this to open this, we are getting negative. All right, so 6 multiplied by negative 3, we have negative 18. All right, so this positive turns negative. And from here, we should be having 84. Okay, so that is that on that. I wish we had enough time. All right, I wish we had enough time. So let's quickly take something on the multiplication of matrices. Then we can call it a wrap. Okay. Now, first thing you need to understand about multiplication of matrices, it has to be the same rule and the same column. What do I mean by that? you can only multiply these matrices if you have something like this. 2, 3, 4, all right, 6, 2, 8. Then you have B as, okay, 2, 2, 5, and you have 7, 3, 9. Then you can multiply. You can say find AB, all right, or find BA. Simple. How do you go about it? Now note that this might not be like this in your exam. In your exam, they might just list it like this: 2, 3, 4, 6, 2, 8. B, 2, 2, 5, 7, 3, 9. Find AB and BA. So it's there for it to now rearrange it. So with something like this now, what are you expected to do? You have to multiply the row by column. And when we talk about matrix, this is the row and this is the column. So what we're expected to do now is to multiply this row by this column. Very simple. How do we achieve that? Open a big one. Okay. And from here, we can say 2 multiplied by this 2. All right. Plus this 3. All right. Plus 3 multiplied by 2. Plus this 3 multiplied by this 2. 3 multiplied by 2 plus this 4 multiplied by 5. And we have that. Okay? But it doesn't end there. We are still going to use this same rule to multiply this same column. Are we on the same page? This same rule is still going to multiply this column. All right? This row 1 is going to multiply column 1, column 2. So for the second column now, we have this 2 multiplied by that 7. This 3 multiplied by this 3. This 4 multiplied by this 9. Then we have that. Then we are going to repeat the same thing. Row 2, all right, multiply column 1 and column 2. Let me change that marker, the shade of that marker. R2. So we have C1, C2. The same thing that we did. This 6 multiply this 2. This 2 multiply this 2. This 8 multiply this 5. Then this same 6 multiply the 7. This same 2 multiply the 3. This same 8 multiply the 9. Don't forget to put your plus. And we are done. When I say we are done, not directly done. So from here, very easy now, we can now say, we can begin to multiply. Okay? You can multiply this. If you are multiplying that, that should give you 4. Please, let's begin to multiply. Let's begin to multiply. This should give you 4 plus, this should give you 6 plus, all right, this should give you 20. So we have for this rule. For the second rule, we have, this should give you 12 plus, this should give you 4 plus, that should give you 40. Then we are done. Then we move here. This should give us 14. This should give us 9. And that should give us 36. Then this second row should give us okay, 42, and that should give us 6, and that should give us 72. Do we understand it? And from here, it is easy. From here, it is easy. This is 10. This is 30. This is 50, 52, 56. This is 14. Okay, this should give us 19. All right. That should be giving us 23. 23, this is 23 plus 36. 50. All right. 59. Then this should give us 72. And we have 42 plus 6. That should give us 120. And it's as simple as that. If it was the case of addition, it would have been addition, not multiplication. Like I said earlier, for those of us who haven't done detailed working on the calculator, to our official website, www.star.net, and hit the WhatsApp button to reach out to me after this class. Do have a wonderful evening. Wish you all the best and success in your exam tomorrow. And I want to encourage us as against next semester, let's ensure to enroll early so we can cover a lot together. I look forward to seeing you once again on Space Tutorials, and bye for now.